In this video, I will show you how to sketch a possible graph of f prime given the graph of the original function f. I want you to memorize this chart, which shows the graphical relationship between f, f prime, and f double prime. Pause the video and see if you can draw this chart from memory on a piece of scratch paper. When you're going from f to f prime, you really only need the bottom part of the chart to draw f prime. So let's consider where function f is increasing and decreasing. I'm going to use some vertical lines to separate the graph into intervals of increasing and decreasing. So it seems to be increasing until about here, and then it's decreasing, and it starts to be increasing again about here. Now I'm going to highlight at the top to show where these intervals are. So this is the interval where function f is increasing, and then it's decreasing from here to here, and it is again increasing from here on. But looking back at the chart, remember that wherever function f is increasing, f prime will be positive. Wherever f is decreasing, f prime will be negative. So that means that f prime will be positive in this interval, and this interval, and negative in this interval. As we prepare to sketch the graph of f prime, remember that f prime is the slope of function f. So study the graph of function f looking for horizontal tangent lines. You see we'll have a horizontal tangent line here and here. So at these x values, the slope is 0. So that means that f prime will be 0 here and here. So the graph of f prime should pass through these points. So now we're ready to draw f prime. Because it is positive in the first interval, we will start out above the x-axis. So we're going to go from positive to negative while passing through this point. So now we're in the negative zone, we're below the x-axis, but then we have to pass through this point and we are positive again. So this is a possible graph of f prime. There are others. Problem number 2. Again, let's start out by separating function f into intervals of increasing and decreasing. So it seems to be decreasing from here to here, and then it's increasing from here to here. After this, it's neither increasing nor decreasing. Let's highlight. So this is a decreasing interval from here to here. This is an increasing interval from here to here. And then we have neither, which we will deal with that later. But remember, wherever function f is increasing, f prime will be positive. Where it's decreasing, f prime will be negative. So that means f prime will be negative in this interval and positive in this interval. In this last interval, remember f prime is the slope. And for a horizontal line like this, the slope is 0. So in fact, we can just go ahead and draw that right now. The slope is 0, so f prime is going to be 0 for this entire interval. So we can just draw a horizontal line at 0. But because we have straight lines here, we can do something similar for the negative and positive interval as well. Using points like this one and this one, we can see that the slope in this interval is a constant. Think rise over run. In this interval, we're going down 3 over 6. that is a slope of negative 1/2. So because the slope is a constant negative 1/2 in this interval, then we should draw f prime as a horizontal line at negative 1/2. So this is what f prime will look like in this interval. Similarly, in the next interval, we can use points like this one and this one to see that the slope of this straight line is positive 1/2. This is up 1 over 2. So the slope in this entire interval is constantly 1/2. So again, that means we can draw f prime as a horizontal line at 1/2. And that's really it for f prime. So this is a possible graph of f prime. Notice that because we have sharp turns in function f, we have these discontinuities, these jump discontinuities in the graph of f prime. So you should expect that to happen. Ooh, number 3 looks fun. Look how curvy this is. Let's start off by separating this graph into intervals of increasing and decreasing. So it starts off increasing until about here. So then it's decreasing until about here. And then it's increasing again until here. And then it's decreasing from here to here. And then it's increasing again from here to about here. And then it's decreasing the rest of the way. So let's see. So it's decreasing in these intervals. No, that's increasing. It's increasing here and here and here. And it is decreasing here and here and here. But remember, wherever function f is increasing, f prime is positive. Where it's decreasing, f prime is negative. So f prime should be positive in these intervals, and it should be negative in these intervals. Don't forget about the horizontal tangent lines. Scan for those. So we have horizontal tangent lines here, 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 and here. At these x values, the slope is 0. So f prime should be 0 here, and here, and here, and here, and here. So when we draw f prime, it has to pass through these points. Because f prime is positive in the first interval, we will start our graph above the x-axis. So we're just going to follow the pattern and go through this point. Now we're negative. Then we have to turn around and go through this point. And now look, we're positive, but we have to go back and hit this point. And of course, we're negative in this interval. And then we hit this point, we're positive. And then we turn to hit this point, and we are negative the rest of the way. So this is one possible graph of f prime. Number 4, let's do it again. As always, we will start off by separating the graph into intervals of increasing and decreasing. So it starts off increasing until about here. And then it's decreasing until here. And then, well, I guess I don't need another one because then it's increasing the rest of the way. So this is my increasing interval, and here is another increasing interval. and this is my decreasing interval. But remember, anywhere f is increasing, f prime is positive. Where f is decreasing, f prime is negative. Next, look for horizontal tangent lines. So I see a horizontal tangent line right here, which means that f prime will be 0 right here. Watch out for the fact that we have a cusp right here. There's a sharp corner. We should be expecting a jump discontinuity in this area. So because f prime begins positive, I'm going to start my graph above the x-axis. And of course I have to pass through this point. So I'm going to start off drawing something like this as I pass from positive to negative. But let me pause here for a moment. Notice that in the final interval, function f is linear. So the slope is going to be a constant. We can use points like this one and this one to estimate pretty closely what the slope of this line is. So this is pretty close to a slope of 2 over 5. It's like up 2 over 5, maybe a little bit more than a slope of 2/5. But this is definitely less than 1. So we should have f prime at a constant slope of something that is less than 1. So that's why I'm going to draw a horizontal line pretty close to 0 for the final interval. So that's it. This is a possible sketch of f prime. Let me point out one more thing to you. I told you that when we are going from f to f prime, we only need the bottom part of the chart. Here's why. The top part of the chart says that wherever f is concave up, then f prime will be increasing. Where f is concave down, f prime will be decreasing. Well, let's look back at the graph that we just drew. Notice that function f is concave down in these first two intervals. And according to the chart, that means that f prime should be decreasing in these intervals, which it is. So without even worrying about the concavity, f prime turned out to be decreasing where it should. So basically, the top half of the chart takes care of itself. Let's do one more problem. As before, let's start out by separating function f into intervals of increasing and decreasing. So it is decreasing from the beginning until here, and then it is neither increasing nor decreasing from here to here, and then it is increasing from here to here, and then it is neither increasing nor decreasing for the rest of the graph. So let's highlight these intervals. So again, function f is decreasing from here to here. It is increasing from here to here. And it is neither increasing nor decreasing in the other two intervals, which means that the slope is 0 in these intervals. Remember, everywhere f is increasing, f prime will be positive. Where f is decreasing, f prime will be negative. So that means that f prime will be negative in this interval, and it will be positive in this interval. There are no horizontal tangent lines to worry about, so we are ready to go ahead and start sketching the graph of f prime. In this first interval, where we have indicated that f prime will be negative, we can actually be more specific than that because function f is linear. We can use points like these 2 points to calculate exactly what the slope is. Think rise over run. This is down 4 over 2. So that means in this interval, we're talking about a slope of -2. So f prime is a constant value of -2 in this interval. So we should draw it as a horizontal line at a height of -2. In the next interval, we've already indicated that the slope is 0. So f prime should be 0 for this interval. Let's be careful with the next interval because I see that it is linear part of the time, but then it's curving part of the time. So I'm going to put another divider in here, okay, to separate where it goes from being linear to nonlinear. Because for the linear part, we can again calculate exactly what the slope is. So this seems to go, it's going up 2 over 2. So this is a slope of +1 in this interval. So that means we should draw f prime as a horizontal line at 1. But then after that, we just know that f prime will be positive. It's not going to have a constant slope. Let me come back to this interval because in order to draw it, it will help to draw the 0 interval at the end. So we know that f prime needs to end up at 0 once we get to here. And there are no sharp turns, there are no sharp corners in here. So it should be a smooth transition from this interval to this interval. So that's it. This is a possible graph of f prime.